All right, here we are on number 4 of this week's assignment, the last problem we were asked to do. This is a problem where we're asked to divide two rational expressions. So we'll talk about what happens when we divide rational expressions, and we'll get through it. Now, I would urge you during this time, don't just hold your phone up and photo math the answer. We're giving you this limited number of problems just because we want you to really take the time to understand it. So if you need to look at other videos, if you need to have a few more practice problems, your book is a good resource. You can send me a message. Any of those ways, getting a little more practice on this. Don't just cut yourself short and photo math this and call it a day. So here we are on this problem. So just like the other ones, we're going to look for common factors, and we're going to go through and reduce them before we actually divide this. So when we divide two fractions, we're going to multiply by the reciprocal on this end of the right side. Because if I wrote this as a fraction over a fraction over a fraction, it would be really messy, and that's something that we want to try and avoid. So the first thing I'm going to do is write this as a multiplication problem and then move forward. So x squared plus 2x plus 1 all over x squared minus 3x minus 18 is multiplied by the reciprocal of this right side, or of what it's being divided by. So x squared minus 7x plus 6 over x squared minus 1. So there we have it. Rewrite it as multiplication. There we have it. I touched my face. Okay, on to the next part. So now we're going to factor every single quadratic we have and look for common factors before we actually multiply this out. So looking at the numerators first, because if we look at the numerators first, we'll know already what to look for in the denominators. X squared plus 2x plus 1, perfect square factors into identical factors. So x plus 1, x plus 1. Now if we look at the other numerator, x squared minus 7x plus 6, not a perfect square this time, but x and x gets us x squared. Now 6, we can have 2 and 3. Those do not make negative 7, or 6 and 1, those do make 7. So 6 and 1, and I said negative 7, so we need these to be negatives. The result of multiplying two numbers of the same sign always makes a positive, so that's how we know they're the same sign. So now we're looking for one of these 3 factors in the numerator to appear in the denominator also. So I know what to look for when I'm approaching the denominator already. So x squared minus 3x minus 18. Well, x and x get us x squared. In this case, 18, let's see. We can have 9 and 2. 9 and 2 won't make 3 in any world of positive or negative. We can have 6 and 3. 6 and 3 will make 18, or negative 3 in some world. And we already know we see a x minus 6 here, so I'd expect there to be a x minus 6 in the denominator. So let's look. Does x minus 6 work? Well, if we make a positive 3, negative 6, positive 3 do make negative 3 when we multiply that out, so we're good to go there. Now x squared minus 1, there's only one way to factor this. Difference of two squares factors into the exact same 1 and 1, x blank 1, x blank 1, opposite signs. So let's just do plus and minus in this case. So here we have it. This is totally rewritten in a way that we can look for factors to reduce out. So now we just go through, I just work left to right in the numerator and factor everything I can out. So x plus 1, I'm looking for x plus 1. Well, that's not in the opposite portion of the fraction, so I can't factor that, but x plus 1 factors out. This goes to 1 actually if we need that later. Is there another x plus 1? No other x plus 1s. Is there x minus 6? X minus 6, x minus 6 divides to be 1. And then x minus 1, well, those are conveniently stacked. They reduce as well. So this whole multiplication or division problem in the beginning boils down to a multiplication problem, which boils down to something that can be factored and reduced. So we can say this is equivalent to, well, I'm multiplying by 1 and 1. So if we really want, we can say x plus 1 times 1 over x plus 3 times 1. Well, that doesn't do a whole lot for us, but that's actually what's happening here, is it fully reduces in that way. So this is equivalent to x plus 1 over x plus 3. It's a lot simpler to work with this version of the rational expression or problem than everything else. So this whole part is equal to x plus 1 times x plus 3. So that does it for this week. Next week, look for more videos. Enjoy your weekend.